very special speaker today who is an alumnus of Princeton. So Hannah will introduce Ingrid in a minute. So today we're going to be talking about scientific storytellers. We're going to be analyzing two science communication pieces on YouTube. And what we want to do is recognize the attributes of these works that are effective or that we deem effective, because it will be important that we can use this medium in our own work as well. I wanted to give you a practical example of something that you can use, some of the tools that we're building in this workshop towards. Princeton Research Day is coming up. It's on May 6th of this year. It will be fully virtual, as you might expect. If you don't know about Princeton Research Day, it's a place for early career researchers to showcase their research as well as their creative work. And this year, presenters will be submitting 3-minute videos. So today we'll be looking at videos, seeing what we like about them, what we don't like. And then next week, we'll be talking about creating our own videos. So we can actually use the tools from this workshop to help your submissions for Princeton Research Day, if you'd like. Okay, so I'm going to pass the mic over to Hannah to introduce Ingrid.
Hi, everyone. I'm Hannah. I'm a third-year grad student in chemistry. As Penelope just said, Voices of STEM is a mini-series where we invite scientists, engineers, artists, educators to talk about how to get your voices heard in STEM. So today, we are welcoming Ingrid Ockert as our speaker. Ingrid obtained her PhD in History of Science at Princeton in 2018, where she wrote one of the first comprehensive history of science television. Growing up, she's a fan of Nova's The Elegant Universe. She has written for various magazines, Science, Physics Day, Scientific American. She is currently the Marketing Communications Coordinator at Berkeley Lab. The topic of her talk today is the Scientific Storytellers, the Past, Present, and Future of Science and the Media. Ingrid?
All right. Well, thank you so much, Hannah. Thank you so much, Dr. Georges. I wanted to extend a special thanks to you two for inviting me to return, quote unquote, to Princeton to give a short talk. This means a lot to me because I was a CST fellow a number of years ago, and I really think CST is one of the most dynamic groups on campus, if I can say so. They're doing such great work. You are all doing such great work to combine, the sciences and the humanities. And I wanted to take a moment to also say that I also participated in the Princeton Research Day when it, was in the first couple of years. And it's a wonderful opportunity for students and staff to learn about each other's work. So I hope your students and attendees of this workshop really enjoy participating. And I think that's just great that there's a way to adapt it this year to be virtual. So yes, I am a historian of science, as Hannah mentioned, and that's actually something I think a lot about, even though these days I'm working in a communications role out in Berkeley Lab. In many ways, the research that I did at Princeton actively informs the ways that I think about reaching out to people. In this new role, I'm helping to sort of create a set of scientific branding and works online that will help inspire community college students and university students to pursue internships at Berkeley Lab. And so I think a lot about what excites people about science and how to get people enthused and feel like they are welcome within a laboratory setting. And so my work back as a Princeton student was focused on similar questions. I looked a lot about how scientists and science journalists worked together, starting from the 1950s onward. And I was really interested in the ways that technology changed the presentation of science. And back in the 40s and 50s, that was television. That wasn't just, PowerPoints or anything, but I mean, very basic, looking at the ways that again, basic technology like a visual text would change when presented over a screen. And so when I'm thinking a lot about this, I always start with kind of a basic question, which is, where did we learn about science? How do we know scientific principles? Where does that come from? And so I have to go back to thinking about how I learned about science. And then as Hannah mentioned, I was a child of the 90s, and I grew up with all of these TV shows, Wild Kratts, The Magic School Bus, Bill Nye the Science Guy, Brian Greene's The Elegant Universe. That was my favorite, actually. I loved Elegant Universe. I thought it was a really great show. And so I was really lucky because I grew up in this period in the 90s where there was a ton of science on television. It was like this small bump, which has given, I would argue, as I'll talk about at the end, shape to a wonderful foundation of science communication that we see today across mediums. And again, just some background on me. I don't have a science background at all. I was really interested in science as a kid, but I knew I didn't like lab work. And so I went into literature and communication studies as an undergrad. And I was interested in understanding the stories about science. And that's what brought me to Princeton. Princeton University has a wonderful history of science department. And I do sometimes cross-list classes. So if you're at all interested in ever auditing a history of science course at Princeton, I highly recommend checking it out. That's where I got my training. And I learned to think a lot about the stories of the people who do science, and sometimes the people what we don't know and don't remember. So again, all of this sort of informed my current work at Berkeley Labs, where I think a lot about the ways that we can engage more and more communities. But again, how did this all start? We have Bill Nye the Science Guy, but where does he come from? So the answer is you have to go way back in time, put on the time machine, and go back to the 1950s. And if you go back to the 1950s, science on television kind of looks like this. You have a guy on screen who is like, your very well dressed basic scientist, and he's the guy kind of, nodding his approval. And then you have a communicator of some sort, and he's the guy holding the apple. And then you have a camera person. And in many ways, this sort of trifecta is what you think of as science communication from the 40s to the 50s, really into the 1960s in the United States. There was this idea that scientists weren't very good at communicating. And so they really needed to have an intermediary. And that's, again, where you have a TV host. But where does this come from, you might ask? So it comes from this guy, whose name is Linpool. And he was an interesting guy. He was not a scientist. He was trained initially as a dancer, and he toured with a modern dance company in the 1920s. And then he decided to become a musical producer. And he worked with the Air Force, I believe, to put on musicals and small performances for the troops during World War II. And he was also a dabbler in Greek art. And so he ended up being a curator in Baltimore, working in one of their art galleries. And that's when he was hired by Johns Hopkins University as their public relations director. And so Linpool was given a task as the director of public relations at Johns Hopkins. It was a school well known at the time for their medical program, but the school wanted to have a larger profile nationally. And so he was asked, how can we tell more people about the other great departments at Johns Hopkins University? And again, Poole was open to lots of different forms of media. In addition to the art, the performing, he'd also had some experience in vaudeville. And so he was like, let me see. I'll think about this. And at the time, there happened to be a television studio that was starting up in Baltimore called WAAM. And it broadcast a station that no longer exists, but was part of the 4 stations that existed across the United States in the early 1950s, late 1940s. And the station is called Dumont. And so Linpool did what many of us do. He did an internship. I mean, he was at that point, he was in his mid 30s, but he was like, I want to figure out this whole broadcasting thing. Let's see what broadcasting is all about. And so he hung out at Dumont's WAAM studios for about 6 months, about 6 or 7 months, and then said, okay, I'm starting to get the hang of this. He had talked to the camera people, he talked to the producers, he talked to the lighting people, the set people, and he went back to Johns Hopkins and said, I think I can make a TV show for you now. And so he did a show called the Johns Hopkins Science Review. And the Johns Hopkins Science Review was the very first nationally broadcast science show in the United States. And that was important because, again, if This is a time before everything is interconnected. So it was bizarre, unusual to have a show that could be seen in San Francisco, but also in New York City. And Linpool did this show, and it was, he wasn't a scientist, so he often said that he would ask basically people around the lab for ideas. He might be on a bus and listen to see what people were talking about. He really wanted this to be a show that was for non-scientists, specifically a show that would convince parents to send their children to Johns Hopkins at some point. And so the show went on for 7 years, and it covered a variety of topics. At one point, they went to the moon in a 3-part series with Werner von Braun and Heinz Haber. And the Johns Hopkins Science Review also featured the first X-rays on television. They featured the first electronic microscope on television. They also talked a lot about subjects that were related to health, which made a lot of sense, including showing one of the first live birth on television. And also in an episode that I've never seen, but received a lot of attention at the time, they showed the first breast cancer exam on television. And that was a very special episode. They got viewers who watched those episodes and would write in to say that they had taught their daughters to do breast exams after watching the show. That doing a breast examination for one woman after watching the show helped her find a lump, which she then was able to talk to her doctor about. And so this was actually this very personal side of science is very typical to the Johns Hopkins Science Review. And as we'll talk about later, I think it actually has come back today. But it's not what we would think of at all about a 1950s television show. And really, when you think about 1950s TV shows, you think about this show, which was also on at the same time, but aimed to a different audience. This is not a show for adults. Watch Mr. Wizard was a children's show about science. And it's the very first children's show about science, actually. It was put on by the guy in the middle, who was an actor and a science educator named Don Herbert. He had a teacher's degree in science education, and so, but he was interested in acting as well. He returned to Chicago after World War II and couldn't find any work, and so he decided to create his own. And he had a background in radio, in theater, and he was also fascinated by Scientific American. And so he thought, and he had a couple of young kids at home, and so he thought it would be really fun to create a show that kind of combined all of his interests. And so he created the show called Watch Mr. Wizard. Like the Johns Hopkins Science Review, it was a 20-minute show. Watch Mr. Wizard, however, is different from the Johns Hopkins Science Review. The Hopkins Science Review aired late on Wednesday evenings around 8 o'clock. And it was, again, definitely a show for kids, not for kids, but for their parents to watch after they put the kids to bed. Watch Mr. Wizard was one of the very first shows that we might call a Saturday morning show, because it would air nationally on Saturday mornings. And the idea was that kids would wake up early, they'd get around the television set. And yes, usually it was like one set per neighborhood at this point in the 1950s. So you would have a whole group of kids watching, and they would take notes as Mr. Wizard performed an experiment for the camera. And then they might scramble up and go into their own kitchens and see what ingredients Mr. Wizard used and try to make the experiment for themselves. Because again, this is Mr. Wizard's approach was really about doing science at home. And you can see in this photo, he has a very funny kind of contraption all set up, all to light a candle on the far side of the picture there. And the whole Mr. Wizard motto was that this is the science of everyday living. This is the science in your home. You too can be a scientist. And again, it's really great to think about how inclusive this show was. We might say it was actually very inclusive for the time. At a time when there's a lot of sexism in science, Watch Mr. Wizard teaches boys and girls that they can do science. And Mr. Wizard would write op-eds for publications such as the Girl Scouts, saying that he actually thought that girls could be better scientists than boys. And so no doubt this is because he had kids at home. He had some girls and boys. But also he just believed in children and their ability. And that was a very unusual of the time. And so Mr. Wizard's gamble paid off. The show was exceptionally, phenomenally successful. As you can see that it ran for more than a decade on US airs. It ran on NBC. And there were fan clubs for Mr. Wizard all around the country. There was mail that poured in. And one of the things that I remember when I was going through the mail for Watch Mr. Wizard was just to see how amazing it was that both, you know, boys and girls watched the show, but also their mothers watched the show and their fathers. Again, it was a real family experience. And so this is, however, these are like the shows we're talking about. They're very person-centric in some ways. And there are other shows that start popping up as well. One of the ones we're going to fast forward here, because again, I'm looking at the time and I want to make sure we get to everything, is Nova. And Nova is a show that basically has been with us for a very long time. It's the longest running science series in the United States. It started in 1974 and it just kept on going. It was inspired by a British show, of all things, a show called Horizon that the BBC launched in the 1960s. A producer named Michael Ambrosino saw the show in the UK and decided to come and bring his own version of it over into the United States. And so we brought with him a lot of British science producers. And so Nova actually marks the first show that has a large number of scientific consultants. Mr. Wizard has a scientific consultant, I should note, but Nova is the first show that says to scientists, how about you write the script? How about you talk to our viewers directly about what's going on in your laboratory? And Nova is a show, for those who don't know, that is a documentary show. Basically, every episode looks at a different issue that's happening in science and society, whether that's nuclear weapons or about coal mining or about wastewater or the future of fusion. The early seasons of Nova, to me, are very interesting because they're super political. And finally, again, I would say we're coming back 50 years later almost now to a Nova that looks more like the first few seasons. Nova has had its own phases and phrases. Interestingly, Nova is the very first science show that was funded by the National Science Foundation, and continues to still receive funding from NSF and PBS, along with some other commercial entities. And so what's interesting is that after Nova appeared in the mid-1970s, then there was suddenly a rash of a whole other assortment of science television shows. So we have shows like 3-2-1 Contact that are produced by the Children's Television Workshop, who gave us Sesame Street and The Electric Company. We have shows like Carl Sagan's Cosmos, which is a show that was created by charismatic planetary scientist Carl Sagan, who was based at Cornell University, and actually bears some distinction of being the very first science show that is produced, created, and hosted by a scientist. And then finally, you have a show like Walter Cronkite's Universe that's hosted by journalists, sort of an old school show now, but a show that really looked at the ways that science and science fiction went together. For instance, they did one of the first tours of the Star Wars set, I believe. And that was maybe the first time it had been seen in a science show per se. And from the 1980s, the boom continued. We go into the 1990s, and there were even more shows, by the way, that popped up in the mid-1980s about science. There were shows like Watch Mr. Wizard 2, Beakman's World, Newton's Apple. The National Science Foundation underwrites more programming for kids, like Bill Nye the Science Guy and the Magic School Bus. Scholastic gets involved, Disney gets involved, and we end up in a world that we are in today, which has just a lot of programming about science all the time. And I would say, and note I say programming, I'm not saying television, because by now we've gone beyond television. Two of the shows that I've featured here are TV shows in name only. Emily's Wonder Lab and Connected are both shows that appear on the Netflix platform. Eleanor Wonders Why still is broadcast, but it also is streamed. And these, by the way, were just three shows that came out in the last year. I mean, it seems that every year there's more and more and more and more and more science broadcasting. And so, in fact, as I'm kind of wrapping up here, I think a lot about the shows that I'm excited about and the ways in which we've gone beyond sort of the model of the host talking to the screen that I showed you at the beginning, where you had a host, a scientist, and a camera person. These days, a scientist is able to do actually all of those roles. They can usually host a production, they can cut footage, they can stitch together audio. And I think these are three productions that are ones that think are really great when I think about scientists who do it all. Science Friday puts together an excellent series called Science Fiction that looks at the history of science in words. It's a podcast series. Nova Science Studios, from its 1970s roots, has continued to flourish and currently is offering training courses for science communicators, which teach scientists how to do video productions. And Story Collider is an incredible nonprofit that exists that allows scientists to practice telling emotional stories about science to each other and to audiences, and to really hone their storytelling abilities. And so, as you see, when I start by talking about scientific television, really what I'm talking about is scientific storytelling. And I wanted to close with this poem that I really love that comes from a 1950s era science, like not a science storybook, it's a television storybook that says, television is an action, then a picture, then electricity, then radio waves, then electricity again, and finally a picture again in your receiver all in an instant. Because I think that really captures the dynamic of the medium and how the mediums change. We have TV and podcasting and streaming. But the actions are very similar. This is all just storytelling through electricity and through visual communication and everything. It all becomes mixed up. And what it is television is an action. Science is an action. So anyways, that's a very, very brief run through about the history of science television. And if you're interested in it, you're welcome to read the copy of my dissertation that is over in Mudd Library. Also happy to answer any questions because I ran through that very quickly. I wanted to take a moment and thank one of the major research partners that I've had, which is the American Archive of Public Broadcasting. If you're a scientist and you're at all interested in the ways that scientists have done great storytelling through public broadcasting, I highly recommend checking out this free resource. There are over 50,000 hours worth of television and radio, and they're just fantastic. So anyways, yeah, thank you very much. And I'm happy to take questions and talk more.
Thank you, Ingrid. Any questions for Ingrid?
I have a quick question for Ingrid as the participants are typing, but I was really paying attention to the sense of time that you were talking about. So 20-minute show. Oh, am I frozen?
Oh, just no worries.
Okay,
It just
20 minutes.
A bit of a lag. You know, I'm on Mars here, so
Okay.
it's sometimes
Right.
It takes a while.
Stop. So 20-minute shows selected at a particular time of day for a specific audience, and science communicators don't have that luxury anymore of choosing and packaging that way. So what do you think that's going to do for the attention? Is it saturating it, or?
Yeah, I think that's a really excellent question, Penelope, because I think not just the attention has changed, but the way that in the 1950s there were only 3 channels. If you're interested in science, or if you weren't interested in science, you basically would turn on the television and you had a fairly high chance that you might run into some educational content because that was the only thing on. I think because people have so many options about what they can watch now, it means that it drives the sort of the condensing of science shows. And science spots, it means that something needs to only be a couple of minutes long because someone's not going to stick with a 20-minute documentary anymore, or certainly not an hour-long documentary. And similarly, it means that in order for something to really last, in order for people to really feel like they want to continue watching, it's very important to create a sense of connection between a host and an audience. And I think that's where Carl Sagan actually did some wonderful work pioneering this technique because his documentary series was multi-part, multi-week, and people tuned in week after week after week to watch it. And similarly, people will do that with Neil deGrasse Tyson today, Bill Nye as well, and as well as some other more up and coming YouTube stars.
Cool.
Thank you.
So with YouTube, we are decentralizing the communication of science. That way, we also bring challenges to catch attention.
Yeah.
Yeah. How do you think of the challenge of balancing the trustworthiness of your knowledge, since we have so many YouTube videos and there are a lot of possibilities for misinformation?
Yeah, I think that's a great question. It's one I thought about a lot this year, especially. And I think this is where we actually are well suited to look to other countries to see how they've handled this, because the US was one of the very first places to start to put together science communication. It's worth noting that the Johns Hopkins Science Review trained people in India, in Lebanon, in France, and Mexico. So they did export some of their style in some ways. But if we think about how other countries handle science communication and trust, I think about the BBC and the UK, which during the coronavirus outbreak did a pretty good job just handing, every night updating people and handing them a sort of an accurate, very concise and condensed version of what was happening day by day. And I talked to science communicators over in the UK, and a lot more of them seem more reassured than we are. And I think that's in part because the BBC is a brand, and a lot of people trust it as a brand. And so, I think when we're trying to figure out how to package science, not even package, but how to communicate it in ways that people trust, it's a lot comes down to forming personal connections early and creating platforms that people can stick with for not just 1 year, but 2 years. And again, as Penelope said, that's challenging when these days we only have 2 or 3 minute clips.
Yeah. Good. I have another question. In the cartoons of 1950s, we see that science TV was really male dominated and visually biased. But for Mr. Wizard, he has this really progressive idea that boys and girls can both do science, everyone can do science. So personally, where does this belief come from? From his personal careers?
Yeah, this is something that I've been interested in understanding as well, because we do have a narrative, and certainly it's a very true narrative that in the 1950s and before, certainly there are women who are discouraged from going into science, and there are a lot of science communicators and cartoons in the 1960s that make fun of women in science, and one thing I would say is that for people like Mr. Wizard, but also for Linpool, who I mentioned, they happen to be fairly progressive. They both had featured women scientists on, well, Linpool featured women scientists on his show. Mr. Wizard featured girls in every other episode of his. And I think it's because, if I take a guess, I think it's because they were both people who had a background in the humanities, actually. And I think the humanities, certainly the world of theater, was filled with women. And I don't think it would have occurred to them to think that women couldn't have been any less. So, because they had female colleagues. And so I think actually it's partially because of that, but I don't really know. And certainly I can say that it's really interesting that you can see all the way through that women are just absolutely, they're always just as enthusiastic in the audiences as male viewers are. They're always just watching these shows. So there's always interest actively on both sides.
Great. We need to win in every domain of life.
We have a comment in the chat. Omar, would you like to read it or would you like me to read it? You can turn on your mic if you want and your camera, or I can read it too. Okay, I'll read it. So he says, those shows work so good because storytelling encoded in human brain. Even today, if a person is told to pay attention to speech, which is fast and totally random, then they will get distracted. One of the masters in storytelling was Steve Jobs, and that's how he holds up his audience for 2 hours. And the skill he learned while working with Pixar Studios.
That makes sense. Yeah, that's absolutely, totally. And I think Pixar does some really great scientific storytelling actually as well. I think one of my favorite movies, I don't know, Amar, about you, but I really love WALL-E. Always loved it. And it tells us really interesting messages about the ways that perhaps robotics will shape our future.
More relevant now even than when it came out, probably.
Oh, yeah. Actually, I should rewatch it. Totally.
I thought it was so interesting as you were talking about this longevity of a relationship with your storyteller and how we're sort of lacking that right now, in that the Johns Hopkins relationship has come full circle, because this is just anecdotal. I don't have any evidence actually, but it seems like the COVID Resource Center has been the most cited that Johns Hopkins put out. So I'm wondering, there's probably no relationship, but the fact that they've been a storyteller all this time to us, are we then accepting their message, or were they just very organized and putting a good site together? I'm not sure.
I think they're very organized and putting a good site together, but clearly they've always cared about good communication. And I think universities, actually, I think what it really shows, Penelope, is that in times of stress, people trust the messages that universities will talk about and promote, because at the universities you have so many experts, and so yeah, that's definitely, I would say that's the area of overlap. But also, that's hilarious. I hadn't thought about that. Thank you. I'll have to include that in future presentations.
So any other questions from the group for Ingrid before we move on? Oh yeah, Katie.
So I'm kind of interested in what you think of like representation of like scientists or people like involved in science and just television in general. I'm thinking of like famous TV shows like House or Bones or like Grey's Anatomy or like The Big Bang Theory or like Silicon Valley, like people like who are like working in STEM fields, and like those kind of shows like kind of tell like fictional stories of like daily lives of these people, and like sometimes it could like perpetuate stereotypes or like kind of paint a picture of like what like lifestyles or like what personalities are like in that field. Like I wonder like how you think that affects people's perception of science in general.
Oh yeah, absolutely, Katie. Absolutely. I think you raise a great point as well, which is that these science fiction shows and science fiction dramas are just as influential in people's ideas about STEM as science educational shows. And that has always been the case. I would argue that Star Trek, the original series, when it aired in the late 1960s, was arguably one of the most influential science shows of its time, even though it's not science education, it's science fiction, and it was always meant to be science fiction. So there's some great writing on this by scholars like David Kirby, Margaret Veidekamp, who talk about the ways that when people view these science shows, they think about sort of what science should look like. And it really ends up shaping their ideas of what scientific research does look like. And so when scientific research doesn't match their expectation, then they get really confused. But again, back to your main point, which is these shows do end up opening up more, I think, roles in that people watch people who are from underserved communities and underrepresented communities will watch shows like a drama like House and think that they maybe see themselves portrayed, and then they may become more inspired to go into a scientific career. The example of this that a lot of people cite in terms of a fictional show is X-Files, which is not a science show. It's a show about pseudoscience. But it was super influential in the 90s because of a main character named Dana Scully. And so many women watched Dana Scully who was this like scientific character. These women ended up becoming like scientists themselves. And the Gina Davis Foundation surveyed a bunch of people and asked them about, did you watch the show growing up? And overwhelmingly, scores of women said that they had watched Dana Scully and they loved her as a character. And so it's been termed the Scully effect. And I think that's the most well-studied direct example of that. Again, in terms of science communication, for the science education shows themselves, there's a show called 3-2-1 Contact, and that's the very first science show that takes seriously the idea of representation, that says that we need to make sure that on screen we have not just white children, but children who are Black, Latino, Asian, showing that kids can do science on television, and that then it was a show that also brought on scientists who were Latino, Black, Asian, to show that there are scientists from those backgrounds within different scientific fields. And that was a show that came out in 1980, and it really laid the groundwork for a lot of other science education shows, making sure to prioritize representation on screen. I think in general, the industry has done a much better in the last 50 years, certainly. But it's always really interesting to see how science fiction impacts our realities about science. So thank you for the question.
We have one more question from Evan. How would you advise advanced degree scientists to approach science communication to the public? Some of the TV show hosts you mentioned did not have formal science backgrounds and were very successful. It can be hard for scientists to forget what is jargon and what is accessible to the public.
Yeah, and I think that's a great question. I want to assuage some of your concerns and say I'm talking about the shows I'm talking about were very, very long ago. And so actually, if you look at the shows and even the podcasts that are done these days, I would say that arguably 60% of the new, I feel like every science journalist I've met in these days actually has a background in science, whether that's a PhD or a master's degree in science. So it's actually very common these days, and and so I think it's really great that people are thinking, even in grad school, about ways to start to streamline their own communication and to not get lost in jargon. So we learn a lot of jargon in grad school. I remember I learned a lot of jargon in history that I wouldn't use now, for sure. And I think the best way you can do it is to just practice. One of the people who did it best and did it well was Carl Sagan. And I think it's worth noting that Sagan, by the time he was on Cosmos, he had been on television on and off for about 20 years. Like he had put in, I mean, even though television that wasn't that old, he had put on a lot of time appearing on doing interviews, appearing on talk shows, and other scientists also have done this. Bill Nye, who's technically, I guess he's an engineer, not a scientist, he started out by doing stand-up when he was working at Boeing. And from that ended up sort of actually building out a career in television just by appearing on late night TV shows in the Seattle area. And so I would say the best way to get over putting scientific jargon in your presentation is you just practice. And that's why organizations like Science Collider are fantastic, because they do like little workshop series where you can just sort of practice workshopping stories about you and stories about your research. And then you can, perform it for a small audience. But yeah, and I think I'm really impressed to see that that there are so many opportunities at Princeton these days to practice. I noticed that the folks who you were interviewing for your first session organized, I forget the name right now, of the new science website that's
Princeton
all about
Insights.
yeah, Princeton Insights, and that wasn't around when I was in grad school at Princeton, and I was reading about it and I was thinking it was just so amazing. And it was like, so I mean, I clearly, and some of you might already be involved in that, and it just seems amazing. So I would just say just look for opportunities. And when I was at Princeton, actually, I was on a radio show for a number of years called These Vibes Are Too Cosmic, that was hosted by a guy named Brian Krause. And the reason I did that show was so I could go on once a month and I could just talk and talk and talk. So I would get used to talking on radio. So yeah, thank you so much for the question.
Thank you.
Thank
Do you
you.
have further questions? I can post it here, and Ingrid can answer later. Good. Today we are going to analyze two YouTube videos. Very popular these days, YouTube videos on science. So I will screen. I'll share my screen.
So
So
just to
there
set it up, we had a hard time choosing videos because, you know, the length is really critical, as we've discussed a lot, but we wanted to show you two similar content videos and then discuss the differences and try to tease out what's effective out of each one.
So you can open the Mural link to post some draft of what I like, what I don't like for our discussion later.
Oh, I love this. This is so cool. I've not seen the interface before. Really awesome.
Developing vaccines is usually a very
Can you hear the sound, everyone?
Yeah.
Yeah, good.
lengthy process, taking on average 8 years to get approved. Since a few years, we have the ability to create mRNA vaccines, which can be developed much faster. So how do these vaccines work? Are they safe, and how do they compare to traditional ones? But first, you must understand how the immune system works. When a virus enters your body, it will attach itself to one of your cells and inject its DNA or RNA into it. This is like a blueprint for your cells, containing instructions on what the cell has to make. So in this case, the virus's RNA will tell your cell to make more copies of the same virus. They become factories, assembling new copies of the virus that can infect even more cells. But don't worry, our bodies have a defense system for foreign intruders. The immune system attacks any protein, virus, or bacteria that does not belong in our bodies, but it takes a few days for it to learn how to attack the intruder. Meanwhile, the virus factories are running non-stop, quickly replicating the virus and spreading it in your body. In other words, you start experiencing symptoms of whatever has infected you. After a few days, however, your immune system will have figured out how to attack the virus and will start producing antibodies. These attach themselves to the virus, preventing them from infecting more cells and marking them for destruction. As you can see, the immune system is remarkable, but it's slow to mount an attack. That is the reason why we can get sick in the first place. So to give it a helping hand, we developed vaccines. The main idea is to train your immune system to recognize and fight off an infection before it has occurred. Almost like showing your immune system a mugshot of the virus and saying, if you see this, kill it. There are various types of vaccines, but let's take a look at the new kid on the block, mRNA vaccines. To understand how they work, let's take the COVID-19 pandemic as an example. You might have seen pictures of the virus with its distinctive spikes. These spikes allow the virus to attach to specific cells in your body and infect them. Now, here's the key idea for the COVID-19 vaccine. What if we could train our immune system to recognize these spikes by having our own bodies produce them? To do that, researchers took the virus's blueprint, its RNA, and isolated the part responsible for producing the spikes. Armed with this blueprint, they created mRNA, or messenger RNA. This is a special form of RNA that can enter your cells and give them instructions. In this case, the RNA contains instructions to build the spikes of the coronavirus. Not the virus itself, just the spikes. So mRNA vaccines contain instructions for your cells that tell them to build a part of a virus in large volumes, almost like giving them a recipe to follow. Once this is happening, your immune system kicks into action and starts learning how to attack these intruders. Again, it takes some time for the immune system to fight off these spikes, but you won't get sick because it's only the spikes, not the virus itself. And that's it. Your immune system has learned how to attack the spikes of the coronavirus. It destroys all the spikes and even breaks down the mRNA vaccine itself. The only thing left in your body are special B cells or memory cells. These can linger around for months or years until the same virus infects you again. When that happens, the B cells can produce the correct antibodies right away, preventing the virus from spreading and making you sick. What's interesting about this mRNA technique is that it's relatively quick to develop a vaccine as soon as we know the DNA or RNA sequence of a virus. And secondly, because the vaccine only makes our bodies produce a tiny part of a virus, we cannot get sick from it. More traditional vaccines use weakened versions of the actual virus. This also triggers an immune response, but could also give you mild symptoms. Now you know how mRNA vaccines work, but don't take my word for it. All sources used to make this video are listed in the description below. Check it out if you want a more in-depth explanation. Give this video a thumbs up if you found it interesting.
Great. Another video, very short, on the same subject.
How does an mRNA vaccine work? mRNA vaccines can be manufactured faster and more cost-effectively than conventional protein-based vaccines. But how do they work? To develop a coronavirus vaccine, researchers selected an mRNA that encodes the coronavirus spike protein. This protein helps the virus enter a human cell. First, the mRNA is prepared by in vitro transcription or chemical synthesis. Next, the mRNA is encapsulated with lipid nanoparticles. This layer protects the mRNA and raises a stronger immune response. The final vaccine formulation is injected into the skin or muscle. Once the mRNA enters the cell, it uses the cell's translation machinery to produce the viral spike protein. The spike protein triggers the body's immune response to produce antibodies and specialized T cells. During future exposure to the coronavirus, these antibodies and T cells will attack the virus, preventing the development of COVID-19.
Great. Oh, any opinions on these videos? Oh, which one do you prefer, and what do you like or don't like that much about both videos?
Hannah, I think I'm going to ask that we go into breakout rooms
Okay.
because I think we'll have some more chatting going on, and then we'll meet back in about 5-10 minutes to discuss. Okay, so let me
I
make this.
hope you guys don't mind. I'm going to cut out, actually, if that's all right.
Ingrid, thank you
Wonderful
so
to chat
much.
with you all. Have a
Thank
good afternoon. Bye.
Bye.
Thanks.